Have you ever found yourself staring up at the night sky, pondering what will happen when the universe comes to its end? A thought-provoking question, isn't it? And one that holds great significance. After all, understanding our universe's fate is part of understanding our place within it. There are various theories out there, each offering a unique perspective on how everything might cease to exist. But fear not, for we are about to delve into the depths of these theories. So, let's embark on this journey through time and space to explore the possibilities. To understand the end, we first need to understand the beginning and the life cycle of our universe. Let's start with the birth of everything we know. Around 13.7 billion years ago, a singular point, infinitely hot and dense, suddenly expanded. This moment, known as the Big Bang, spewed out all matter and energy, setting the stage for the universe as we know it. Post-Big Bang, the universe was a hot, dense soup of particles that eventually cooled down as it expanded. It's a bit like letting a balloon full of air loose. As the air escapes, the balloon deflates and cools down. Similarly, as the universe expanded, it cooled down, allowing atoms to form and eventually leading to the creation of stars and galaxies. Fast forward to today, the universe still continues to expand, but it's not just stretching out, it's actually accelerating in its expansion. This is due to a mysterious force we call dark energy, a concept so elusive we're still grappling to fully understand it. Now let's talk about time. Time as we perceive it is intimately linked to the life cycle of the universe. In the grand cosmic scale, time is not a constant stream but rather a fabric that bends and stretches with the universe. It began with the Big Bang and has been ticking away ever since, intertwined with the expansion of cosmos. So, what's the current state of our universe? It's vast, still expanding and filled with a multitude of galaxies, each brimming with billions of stars. Some of these stars have planets, and one of those planets is our Earth, a tiny speck in the cosmic ocean. But remember, the universe is not static. It's a dynamic, ever-changing entity, governed by laws of physics and cosmic forces. Its birth, life, and eventual death are all part of a grand cosmic cycle. With this understanding, we can now explore the theories about the universe's end. One of the most widely accepted theories about the end of the universe is the Big Freeze. Imagine a universe continuing to expand indefinitely, with galaxies drifting farther and farther apart. As the universe grows, so does the cold emptiness of space. This is the foundation of the Big Freeze scenario, a concept that paints a frigid picture of our universe's potential fate. The Big Freeze is predicated on the idea that the universe will keep expanding at an accelerating rate. The fuel that drives this expansion is dark energy, a mysterious force that permeates all of space, pushing galaxies apart. As the universe grows, the density of matter and energy decreases, leading to a steady decline in the universe's temperature. Over trillions of years, stars will run out of nuclear fuel and cease to shine, their light fading away. The universe, once ablaze with the light of countless stars, will become a dark, cold, and empty place. This is the Big Freeze, a universe growing colder and darker with each passing moment. But what does this mean for the universe and everything within it? Well, the implications are profound. As the universe cools, the processes that fuel life as we know it will grind to a halt. The stars will burn out, and without their energy, life, at least in the form we understand, will be unable to exist. And yet the Big Freeze is not a sudden event but a slow, gradual process spanning over trillions of years. This gives life, in whatever form it may exist in the distant future, a vast expanse of time to adapt, evolve, and perhaps even find new ways to survive. The Big Freeze paints a stark picture of a universe slowly winding down, its energy dissipating, its stars fading, and its life forms facing an uncertain future. Yet, it also highlights the resilience of life and the potential for adaptation and survival against all odds. It's a chilling end, isn't it? But there are other theories too. Another theory is the Big Crunch, which leads to a theory called the Big Bounce. Now let's take a moment to dive into this fascinating concept. The Big Crunch paints a picture of a universe that, after expanding for billions of years, eventually slows down and starts to contract. Imagine it like a balloon being inflated and then deflated, but on a cosmic scale. This contraction is not a slow, gradual process. Instead, it accelerates, with galaxies, stars, and eventually even atoms being drawn closer and closer together. The universe becomes denser and hotter, until everything is crushed into a singularity, a point of infinite density. This is the Big Crunch, the mirror image of the Big Bang that started our universe. But what happens after the Big Crunch? This is where the idea of the Big Bounce comes into play. The Big Bounce theory suggests that the singularity created by the Big Crunch could trigger another Big Bang, causing the universe to start expanding again. This could imply that our universe is just one of many in a cyclical series of universes, each beginning with a Big Bang and ending with a Big Crunch, in an endless cycle of creation and destruction. This is a beautiful, almost poetic vision of the universe. It suggests a universe that is not heading towards a cold, bleak end, but one that is constantly renewing itself, like a phoenix rising from the ashes. It's a universe that is not just born once, but is reborn again and again. However, it's important to note that the Big Crunch and Big Bounce are just theories. They are based on our current understanding of the laws of physics, which could change as we learn more about the universe. For now, they provide a tantalizing glimpse into the possible fate of our universe, and remind us of how much there is still to discover. So, it might not be the end, but a new beginning. But there's another theory that's even more dramatic. The final theory we'll explore today is the Big Rip. This idea, as ominous as it sounds, proposes a rather violent ending for our universe. Picture this: everything, yes everything, being torn apart, from galaxies and stars, right down to atoms themselves. The Big Rip theory is based on a type of dark energy that doesn't stay constant, but rather increases over time. As this dark energy grows, it pushes galaxies further and further apart, but it doesn't stop there. As the dark energy becomes more powerful, it begins to overcome gravity on smaller scales. First, it would rip galaxies apart, sending stars flying into the abyss of space. Next, it would overpower the gravity holding solar systems together. Planets would be flung from their orbits, drifting alone in the darkness. After that, even the stars would be torn apart. Eventually, the theory suggests, this destructive force would become so powerful that it would tear apart everything down to the smallest particles. Now you might be wondering, what conditions would lead to such a catastrophic event? Well, it all depends on the behavior of dark energy. If the pressure of dark energy is less than -1, then a Big Rip scenario could unfold. But before you lose sleep over this, it's important to remember that the Big Rip, like all theories about the end of the universe, is just that, a theory. It's based on our current understanding of the universe and the mysterious dark energy. As we continue to explore and learn, our theories may change. Moreover, even if the Big Rip were to happen, it's not something we'd need to worry about anytime soon. We're talking billions and billions of years into the future. It's a violent end, tearing everything apart, but remember, these are just theories. Each one offers a different perspective, a different potential ending, and each one reminds us of how much there is still to learn about our incredible universe. So, what does all this mean for us, and for the universe? We've traversed the intricate cycle of the universe, delved into the chilling depths of the Big Freeze, explored the crushing reality of the Big Crunch, reveled in the rebound of the Big Bounce, and confronted the tearing terror of the Big Rip. Each of these theories, each of these possible endings paints a different picture of our cosmos's fate. While our understanding is still evolving, these theories give us a glimpse into the grandeur of the universe. They open our eyes to the fact that our existence, our reality, is but a fleeting moment in the cosmic timeline. And though the end may seem daunting, it's a reminder of the beauty of the cosmos, of the mysteries it holds, and of the unending quest for knowledge that drives us. Whether the universe will freeze, crunch, bounce, or rip, these outcomes are billions of years away. Yet they serve a crucial purpose. They remind us of the universe's transience and our place within it. They remind us that we are part of something far greater, far more complex, and far more mysterious than we could ever comprehend. The end of the universe is billions of years away, but the thought of it, whether it's a freeze, a crunch, a bounce, or a rip, certainly puts our existence into perspective, doesn't it?